All right, good morning, everybody. Welcome to week 7 of CNET58. Today, we're going to take a brief look at setting up servers to host websites. So our focus is going to be on both our Linux machine, CentOS, with the web hosting service known as Nginx. And then in Windows Server 2019, we'll look at hosting a website on the Internet Information Store, or IIS. So we'll spin up a couple of VMs, 2 new VMs, and 1 CentOS and 1 Windows Server. And then we'll install the appropriate software. And then we'll configure the software to host a website. And then we'll test it from our Windows 10 client. All right, so that's basically what we're going to do. Today's lecture is just going to be kind of an overview of what is IIS and what is Nginx. So we'll have opportunities to look at some material for both of those hosting platforms, and we'll go from there. All right. I did want to mention that next week is our midterm. So both our written midterm, which will be administered on Canvas, which is going to be 100 questions, multiple choice, true, false, and some fill in the blank, short answer. And that exam, I have it available all of next week. So from Sunday or Monday morning at 12:01 a.m. on the 12th, all the way through Sunday night at 11:59 p.m. on Sunday night on the 18th. Right, so that's the midterm exam. The lab midterm will also be available all of next week. And what I want you to do is, as soon as you're done with the lab midterm, email me so I can assess it, go in there and grade it, because I need to, between now and next Tuesday, I need to grade all your lab midterms and reconfigure the servers for Hyper-V so we can use those in week 9. So it's gonna be a quick turnaround on that, but it's a process I can get taken care of probably in a day or so. All right. Are there any questions on kind of where we're at in terms of the mechanics of the class, the schedule of the class? Okay, Ian, thanks for popping in the chat. He says, I don't have any, everything sounds good to Frankie. Good. There is no time limit. Both of the midterm test is open book, open note, open whatever resource you want to open, and there is no time limit. However, you can only attempt it one time. The lab midterm is open everything that you have access to, and then just let me know when you're done with it. Send me an email that says, hey, I just submitted my lab midterm for grading, and then I'll go in and get that graded as quickly as I can. Now, just like anything that, if we've learned anything, I think me as a professor and you as a student during this online season, is don't procrastinate. Don't wait until, Sunday afternoon to say, well, I'll take the midterm and then I'll do the lab real quick. I can almost guarantee if you take that approach, you're going to have some frustrations because things don't always work out the way you had hoped they would. So, do yourself a favor and get online and do that stuff. Now, next Tuesday, from 8 until 3, I will be on Zoom. So I will open the class meeting. And if you need anything, just pop in and let me know. Now, I'm going to tell you right now, I will not give you any assistance on the lab midterm other than if you have a really technical problem that is preventing you from accessing or doing the lab itself. If you just don't know, well, how do I do this? How do I install this service? My answer is going to be, I'm sorry, but I can't assist you on that. So I'll be available. I mean, I'm still going to hold class. It's optional for you if you want to pop in or not for next Tuesday, because really you have all week to do the midterm exam and the lab midterm. And remember, the lab midterm is going to look very similar to lab 5. So the lab we did 2 weeks ago, where we did the file sharing and the Active Directory and the DHCP and the DNS setup in Active Directory on Windows Server, that's what the lab is going to be based around, that type of an environment. All right. Any other questions? Comments? Complaints? No. All right. Well, let me share my screen and we'll get going on today's lecture material, which is not going to be very long. So let me move some stuff around. Hopefully you can see my screen here. If you go into week 7, you can see the lecture 7 lecture material, week 7 lecture material, and then lab 7, then the week 7 video. Again, this week I did create a video that will walk you through today's lab. Many of you said that you like that. I will also take the opportunity to demo today's lab when we're doing the lab. I'll just randomly pick somebody and we'll use your machine to get it started. But what I want to look at here is the week 7 lecture material. So I have several links in here that talk about what is a web server, what's IIS, and then what is Nginx. Most of these are videos, with the exception of this first one, which is this website that says, what is a web server and the type of web servers. So how many of you, have any of you built your own website? Like you have a site somewhere online? Okay, Louis said no. Frankie, it's not online. Where is yours if it's not online, Frankie? On your machine, okay. Just to kind of test stuff out. Yeah, perfect. I mean, as a technician, that's something you can easily do. Now, for those of you that took CNET58 in person, we do a website, or we do a lab where we install IIS on Windows 10, which is very easy to do. It's just, add features, IIS, and away you go. So good on you for that. Anybody else? Does anybody have a website online that you've designed or you've set up? It's pretty easy. I mean, you can register a domain very simply, with any of the hosting companies. And then you can, get your domain name and then find a site, either Amazon Web Services, AWS, or Microsoft Azure, and get a virtual machine that you can spin up in a matter of probably 10 minutes, and then install your website and away you go. So it's fairly easy to do. There were a lot of web hosting services way back when the internet was, maybe a lot younger than it is now. And there were sites you could actually spin up a website on, and it would host and you could build your own website. There's a lot of WordPress sites that are still like that you can build a pretty simple site. And I wouldn't be surprised if this Miles blog or Miles web over here is not hosted on some sort of machine. In fact, at the top it says India's #1 web hosting company, and you could get a WordPress site pretty easily right there. All right, so let's look at this website. So I'm going to make the font a little bigger just so you can see it. So what is a web server? Understanding a web server and types of web services. servers, a program that uses HTTP. Now we know from our previous studies, is particularly in the networking environment, that the hypertext transfer protocol is a TCP protocol, which means it's guaranteed delivery. And it operates on port 80. So when we create a website, one of the things we have to be aware of is we have to, on that machine's local firewall, we need to allow traffic in to the port 80. If we block, we could have like Frankie could have his website running on his local machine, and it would only be accessible on his local machine unless he punched a hole in his firewall and told it to direct traffic into his local machine. And now in that case, because his site is on his local machine and he wanted it from the internet, he'd have to do what's known as port forwarding, where he'd have to tell his router, take this traffic coming in on this port and send it over to this IP address and port or socket on his local machine. Okay, so it uses HTTP for serving files that create web pages for users in response to the requests that are sent by the HTTP clients of their computer. And that whole process is known as a web server. And web server support is still something almost every single company has a web presence, right? And you could probably argue that the company's website is still the #1 resource that customers and users of the product will go to find information about a company, or to find information for support, or to find information about a product, or to find information about, you know, the employee. So that's probably still the de facto standard for information about a product or a company. But the social media presence has probably overtaken the web presence as far as outreach. So like as far as advertising and word of mouth and getting, you know, data out to the users, the social media, whether it's on Instagram or Facebook or Twitter or any other social media platform, the advertising return on investment from social media is greater than it is if you just do what used to be called search engine optimization, or SEO. So although web search optimization is still important. I mean, if you have a website for, let's say, you're selling classic Nintendo games, which, by the way, you probably saw where that version of Mario Brothers that was unopened sold at auction for over $600,000 for a Nintendo game that was in pristine condition, never played, never opened. So, you know, it sent me scurrying up into my storage area in one of my bedrooms, and I was like, oh no, we don't have that one unopened. But I'm just kidding, I didn't do that, but I'm sure people did. Yeah, and like Louis said, to get your exposure, social media is very easy to do that. But their business is on the website. Exactly. That's a really good statement, Louis. But anyway, so that's known as a web server. So if any server delivers an XML document to another device, and the XML is, well, let me start with HTTP uses I'll use the word programming language. It's not necessarily a programming language, but it is a language you have to type certain code snippets in, known as HTML. So the hypertext markup language is commonly used to tell the browser and the server how to display the information. So we're going to do some really basic HTML today in our lab. We're just going to say, you know, the start tag of HTML, the end tag of HTML, and inside of that we'll have a body, then we'll have a paragraph, and then we'll have some text. So, and then we'll tell it what font and how to center it and all that stuff. But another markup language that's kind of evolved from HTML is known as XML, which is the extended markup language. And XML is commonly used in all kinds of data transfer. So whenever we have a front end and a back end server, which most websites have data stored in a database, and then the front end is just the website, and how those two machines communicate back and forth is typically going to be in some sort of markup language or some sort of programming language. Python is very, very common. And a lot of these concepts that I'm talking about today really don't fall within the course objectives or the learning objectives of our CNET courses. But they do squarely fall into the CIS, the computer information systems. So if you like websites and you're like, I want to be a web designer and write code for websites, I would encourage you to check out some of the courses that the CIS department and the business division offer, because they have specialists in courses that really dive into that. Now we're more hardware and, you know, getting things set up and running. Most IT people, especially if you're a server administrator, you're going to know a little bit about HTML and web development, but you're not going to be an expert. I mean, you'll set up the server and turn it loose to the people that are, and that's kind of our involvement with that. All right. So the XML to another document can be a web server. In simple words, a web server is an internet server that responds to HTTP requests for delivering content and services. So the content and the services are as varied as anything that you can imagine on the internet. I mean, if you want to host a website for, you know, maybe your passion is, you know, baking chocolate mousse pies, right? That's your specialty. And, you know, your friends and family encourage you, well, you should put some of this on the website and see if anybody would want to, you know, purchase some of your pies or whatever. I mean, let's say you want to, that was your interest, or, you know, it could be golf club repair. It could be, you know, game hints and strategies, and whatever your interests are, there's probably a website out there. And so if there's somebody with an interest, there's probably somebody that has either created a website or will create a website. There's still a lot of websites are still popping up every year. Even though, you know, you kind of think everybody has been there, done that, but it's still an important feature. So let's take an example. If you're working on your computer, browsing your web, and message pop-ups from your friend that I had just read a great article at the following URL. And the URL, of course, stands for the Uniform Resource Locator. So really, it's the address of the website. And these sites are always written in human readable terms, right? And we know there's a service on our server that converts the human readable terms into IP addresses, and that is what server. What server does that translation work for us? And Ellen's exactly right. The domain name services server. So the DNS converts this www.milesweb.in/blog into an IP address that his firewall and his router can understand, and then it can do the communication. Now, if we were to look at this address, we would say that the milesweb.in is the domain name, just like our domain that we created a couple of weeks ago, cnet.lab, is our domain name. And then the www would be the machine name. So in a lot of cases, this www is an alias. So the machine name, like ours, was server.cnet.lab. And if we put a website on it, we would have it answer to www. So it's just an alias or a pseudonym that says anything looking for worldwideweb.cnet.lab, open this page on this particular machine. And if we combine the machine name and the domain name, and we put that all together, that's known as a fully qualified domain name, or an FQDN. And the fully qualified domain name is the complete address, if you will. Now, most of our browsers, we don't have to enter in the HTTPS://. The browsers will automatically append that to our entry. But some systems, if you can't get there with just the www something, try putting in the HTTP or the HTTPS and you'll have better success. Okay. Now, the web server on which your website is based in the world doesn't matter at all, as the page you have browsed immediately appears in your browser screen. So like if I open another site here, and let's say I just go to Google, this google.com, we don't know where Google has all of their web servers. Now, we know that because of the size of the company of Google, or even Amazon or eBay or any of the big corporations, Microsoft, Apple, pick one, they have multiple websites that are clustered, right? Just like we learned about clustering a couple of lectures ago, that are typically going to be load balanced clustering. And what is the benefit of load balancing versus failover clustering? We'll do a little review for the midterm while we're here. What is the benefit to load balance clustering versus the benefit for failover clustering? Where would we use one versus the other? So exactly, a bunch of you, Alan and Jose, load balancing is used to increase performance, which would make sense on our website, right? We want it, obviously we want it to always be available, right? And that's where the failover clustering is for pure availability purposes, but the load balancing will increase the speed, because if I'm hitting one server and you're waiting for me to finish what I'm doing, or you're competing with the traffic of my request, that's going to slow it down. So they have multiple servers, maybe thousands of web servers that are all serving the same information or similar information to different clients. Okay. Now, a web server, in order for it to be available, it should always be connected to the internet. So when we look at the IP address, there are two classifications of IP addresses, or two types of IP address. We have a public IP address, which by its very definition is routable on the internet. And by routable on the internet, I mean it can communicate across all of the routers that comprise the internet. And remember, routers are the lifeblood of what makes the internet work. So without routers, we have no internet. But the routers can take a IP address that's public, and they can transfer that data anywhere else on the internet. Whereas a private IP address, and there are 3 reserved blocks of private IP addresses in both Class A, Class B, and Class C. And those are non-routable on the internet. So our routers are really computers that have their own processor, their own memory, and their own storage. The code or the operating system for the router will have embedded in it, in its code base, rules that will tell it if it's a private IP address, do not route it on the internet. And what that allows us to do is to use network address translation so that we can have our internal networks on a private IP, but when we want to get to the website, which is a public IP address, it can translate a private IP to a shared or common public IP address so that we don't need every single machine to have a public IP address. Because the address space for IP version 4 is only 32 bits long, which means that's up to a little more than 4 billion IP addresses. And, when the internet started in, the late 70s, that 4 billion seemed like a lot when there was only 5 total machines on the internet at the time. 4 billion seemed unreachable, but now, I mean, it's not uncommon for a typical user, and not really even a power user, like just say a typical family may have 4 or 5 devices in their home that are connecting to the internet. So if you take that times, 7 billion people, now granted, not all the world is as technologically advanced or at the same technology level as everybody else, but on average, that we're way over 4 billion public IP addresses. So we're in the process, and I've been saying this same statement for all of the 10 years I've been teaching at Mount SAC, and I said it before then, we're switching to IP version 6, but the switch is very, very slow. So hopefully there will be a changeover in our lifetime where everything will be IP version 6, and that address space is 128 bits. So that's 340 undecillion IP addresses. And you're probably sitting at home going, did he just make up a word? I've never heard of undecillion. And you're right. Nobody has really heard of it. So it goes tens, hundreds, thousands, millions, billions, trillions, and then quadrillion, and then it's sextillion, septillion, and then we start getting into decillion by the time, well, sextillion 7, octillion, and it just keeps going out there until you're at a number that is so large. Someone would consider, or someone has said, if every single grain of sand in the world, not just in Southern California's beaches, but everywhere in the world, every sandbox, every, cat litter box, wherever there's sand, if every single grain of sand on planet Earth had its own IP address, there would still be leftovers with this IP version 6. So Louis said, with that yearly hardware upgrade, really wonder how many IP addresses there have been since the 70s. That's true. Now, hardware needs both a physical address and a logical address. And the physical address is known as the MAC address. And then the logical address is the IP address. But you're right, they will take up a lot of addresses. So every server is going to have that. Now, each of the web servers has a unique address that comprises a series of 4 numbers between 0 and 255. And that's our dotted decimal notation for IP version 4. So like when you access your ESXi server in your browser, you put in your 10.29.72.54 or whatever your IP address is, and that's in dotted decimal notation. Now with the web server, the hosting can manage multiple domains on a single server. And this is known as virtual hosting. And we're going to set up our websites to have the native host and then at least one virtual host. And we could have multiple virtual hosts on our machines. And so it's not uncommon for like a web hosting company, like say GoDaddy or any of those sites that host websites, to have one big beefy server that has hundreds, if not thousands, of virtual hosts. So even though my machine may be www.mymachine or mynetwork.com and yours may be www.yournetwork.com, they may actually be hosted on the same physical server, but they're in their own virtual area, which we'll see today. All that is a separate folder or directory on the website that you put the code in. And for a simple website, it would just be the HTML code. Okay. Now, there are really four types of web server. Apache, which is the worldwide leader, and then Internet Information Store, which is the one that comes with Windows, Nginx, and then Lightspeed. So let's briefly look at each of these. And Apache, it's estimated that almost 60% of all web servers run on Apache. And you can get Apache for, it's optimized or built or designed, probably would be a better word, for a Linux/Unix environment, but you can get Apache for Windows too. I've done that in the past where I've had Apache running on my Windows box, and it worked great. And Apache is open source, and it's part of the Apache Software Foundation. But it supports almost any operating system. Okay, now you can easily customize an Apache web server due to its modular structure. So it's just kind of building blocks that are there. And that's true of a lot of Linux software, very modular. And because it's open source, you can use your own modules, can be added to the server. You can write your own and go for there. And then the Windows version is this Microsoft IIS, which is the Internet Information Store. Since it's not an open source, it's not as easy to customize. But one thing that IIS has in its favor is that it directly talks to the .NET framework. And the .NET framework is the programming language of all kinds. It's not the programming language is probably the wrong term, but it's the programming foundation that all other programming languages communicate with. So if you write code in C# or in Python or in Fortran or in C or in Java or JavaScript or whatever language, the .NET framework kind of allows all of those different languages to communicate. So it's a lot like Google Translate. So you probably use Google Translate on your phone, where you'll say something in one language and then tell it to translate to another language. Then you just hold your phone and it will repeat what you just said in one language in another language, or vice versa, right? If someone's talking to you and you want to translate it. So the .NET framework is a huge part of IIS. Now, one other thing that it has to be said early on in your web programming career, which I don't know if that's necessarily what you're shooting for, but is the difference between a Linux/Unix environment and a Windows environment. The way you spell or the way you capitalize is very, very important. In Linux and Unix, everything is case sensitive. So if I say index.html with a capital I, and then NDEX is lowercase, and I have another file on my Linux server that's called index.html with all lowercase, those are two separate files. So if you code your links and your shortcuts and all of the stuff that you use all those pages on, you have to be very, very aware of the case sensitivity. So a lot of companies will have a web page naming convention or a standard that says, if it's the first page in a structure, it gets a capital letter, everything else will be lowercase, or however they decide to do it. If you have a Windows machine, it doesn't care. It can be all caps index.html or all lowercase index.html. It will treat that as a single file. So it can be very, very tricky when you migrate from a Windows environment to a Linux environment, because you may find a lot of your links, a lot of your pages that used to work fine no longer work. And it can be as simple as how are they capitalized? Where are the capital letters? All right. So IIS is built into Windows. It's a feature that we can install on our Windows server and on our Windows 7, Windows 10, Windows 8, Windows XP, all the way back to Windows NT supported IIS. All right. Now, Nginx, and this Nginx is the next open source web server after Apache as far as a bit popularity. Now, it comprises IMAP, POP3, and proxy server. So it's a tool or a service that not only does web servers, but it can also do mail serving and proxy serving. So in some environments, that's a very, very handy type of tool to have available. Now, the significant features are high performance, stability, simple configuration, and low resource usage, right? We do not want, and Apache can use a lot of resources. IIS uses quite a bit of resources. So if you're on a machine, kind of a thinly provisioned machine without a lot of processing and not a lot of memory, Nginx may be the best option. Now, if you're doing some heavy duty front end, back end web serving, you probably don't want to go with Nginx. You may want to go with, Apache or IIS. Okay, now, and this, it handles this by the way it works with the processor. So it doesn't create a bunch of different threads. It just uses highly scalable event-driven architecture that uses small and predictable amounts of memory under the load that's utilized. Now, it's become popular, and about 7.5% of all internet domains are going to be on Nginx. And then the last one, and there are all kinds of, this is just 4 of them, but a high-level performance Apache drop-in replacement known as Lightspeed is the 4th most popular web server on the internet, and it's commercial design. So when you upgrade your web server to Lightspeed, you experience improved performance that with a low operating cost. It's compatible with most of the Apache features, such as the .ht access, which is used for authentication and for access control, the mod rewrite, and the mod security. These are modules that are customized for Apache. It can load Apache configuration files, so it can really replace the Apache system within 15 minutes without any downtime. And the benefit here is the speed at which it operates. Okay, there's some smaller ones, Tomcat, Node.js, Lightspeed, and others. So this is just a basic overview of what is a web server. So, a lot of times our impression of a web server is the website we're very familiar with, but the back end or where it's hosted is something that we may not have ever worked with. And that's really what the purpose of today's lecture and lab is to get some experience working on those two things. Okay. Well, let me. All right. So I just had a message I had to look at. All right, so let's go to our next link here. Any questions on what is a web server? Everybody okay? You're feeling good about what is a web server? Okay, good. Frankie says sounds good. All right, so let's go. That was link one or link. Let's go to link one. So this next one is a YouTube video.
Azure includes everything MSPs and IT pros need.
So I'm gonna make this full screen. I'm gonna turn on captioning.
What is a web server? I distinctly remember when I was
skip that the ads. So this is about a 20-minute video. We'll watch this and we'll take our first break. But it's gonna cover a lot of the things I just mentioned, but probably in a little more polished presentation. So let's watch this for a few minutes.
Just first getting started programming, wondering what kind of computers are used to serve web applications? What operating system do they run? How is the hardware different than the gaming PCs? And as it turns out, as is often the case with all of this stuff where you don't know it's this black box you're trying to unwrap, I was asking the wrong question. From a hardware standpoint, anything with a network connection could be a web server. Your laptop, a Raspberry Pi, a smartphone. If you've ever done that dance where you're trying to configure an Internet of Things device and you have to connect to it over Wi-Fi, that Internet of Things device is running a web server. Once you get connected to it, that's what you're interacting with. You see, a web server, it's not about hardware, though certainly some hardware is better suited to run a large web application at scale. Instead, a web server is really just a piece of software that serves web content. But serving web content, that's a tad generic. So let's break it down further and define the 6 things that a web server does in roughly the order in which they happen. So to serve web content, a web server listens on a port for a request sent via a transport protocol and returns a response containing the requested resource. Again, with this list, we're still really abstract. So let's go ahead and take each one of these items one by one for a closer look. So to start, let's focus for a minute on what it means for a web server to listen. Basically, once a web server application starts up, it just sits there, idle, waiting for incoming requests. If no requests come in, then the web server doesn't actually do anything. I think everybody kind of intuitively knows this, but it's important to keep the concept in the front of our minds. To illustrate this, imagine the web server is a guy named Jim who works as a customer service representative at a call center. You can reach Jim by dialing 127-000-0001. And like Jim, the web server just sits there waiting for incoming requests. Jim never places an outgoing call. He just waits and listens. Now I happen to have a web server running right now on my local machine. Of course, it's running on the local host IP address 127.0.0.1. And if we dial that IP address into the browser, you can see this message. Hey, it's Jim. How can I help you? So what exactly is the web server listening to? The answer is a network port provided by the operating system that the web server is running on. Think like Windows, Mac OS. More specifically, the network protocol that we're using provides 65,535 ports that software running on a computer can communicate over. Now, when a web server starts up, it begins listening on one, or if so configured, many of those ports. Going back to the call center example for a minute, let's assume that Jim works at a call center with 65,535 different extensions. It's like a really big facility. And you can reach the call center's main line by dialing 127.000.0.001. But to reach the phone on Jim's desk, you have to dial his extension. Let's suppose that dialing extension 8000 will make the phone on Jim's desk ring. Jim's only listening for calls coming in on extension 8000. And if you dial any other extension, then you won't get over Jim. So let's go back to our demo for a minute. Earlier, when we dialed the IP address 127.0.0.1, we didn't provide a port. And that's because a web browser automatically sends web requests to either port 80 or port 443, depending on whether we prefix the URL with HTTP or HTTPS. In the demo, I had the web server running on port 80 using an unencrypted HTTP connection. So there was no need to specify a port, as the web browser automatically routed our HTTP request to port 80 by default. But let's stop the web server and start it again on port 8000. Now, if we reload the page, you can see we get an error that this site can't be reached as the IP address refused to connect. And that's because there's no longer a web server listening on port 80 on our local host. We can tell the browser that we want our request sent to port 8000 instead by appending the IP address with a colon and then adding the port number. Now you can see, since we've specified the right port to communicate with our server, we've once again reached Jim. Now, just like you could have multiple people working at a call center, each listening for incoming calls on a different extension, so too can you have multiple web servers running on one machine. Let's suppose Jim has a colleague named Jane, who can be reached by dialing extension 8001. If you dial extension 8001, you'll hear Jane speaking, but if you dial extension 8000, you get, "Hey, it's Jim, how can I help you?" For just $67, you can make as many videos as you want, and you never need to pick up a camera or use.
Sorry about the ads, but
software.
that's what you get.
Let's illustrate this by starting a second web server over on port 8001. Sure enough, if you navigate to port 8001, you see the message from Jane, but if you switch back to port 8000, then you get the message from Jim. The point is that one single computer can have many web servers or other networking services running at the same time. And just like we have to dial the correct extension to reach Jim at his desk, so too must we send our request to the correct port in order to reach the desired web server. Speaking of sending a request, let's take a closer look at what exactly sending a request to a web server means. See, web servers and web clients like your Chromes, Firefox, whatever, communicate via the Hypertext Transfer Protocol, or HTTP. And you can think of this as the language that the web server and the web client use. But what does HTTP actually look like? For me, this was the most interesting part of researching this video because of the misconceptions I had about what HTTP actually is. And when they say Hypertext Transfer Protocol, they literally mean text. Like HTTP is just a web browser and a web server sending raw human readable text files back and forth. And I'm sure I'll get comments pointing out that HTTP version 2 and beyond converts the text to a binary before sending, but the point still stands. HTTP is based on text. And I don't know why I thought it was more complicated than that. Well, I kind of do, and we'll cover that when we look at the transport layer later on. But we are talking about the application layer for now, and HTTP is really, really simple. Let's open up this text file here containing an example HTTP request and have a look. That's it. That's a valid request in the HTTP language. So breaking the request down, the data is separated into 3 blocks. The first line is the start line, which contains the request method, which is GET in this case, the request target, which is the specific web page or resource we're requesting. Here you can imagine we're looking up an order on an e-commerce website. And finally, the HTTP version, which in the case of this request is version 1.1. Now the next block is made up of every subsequent line up until the first line break we encounter. These lines contain the headers of our request as defined as key value pairs. Here we just have 2, host, which is the IP and port we're attempting to send the request to, and the user agent, which is the header that tells the web server what type of browser we're using. This can be useful so the web server might know to serve you mobile content in case you're accessing on a mobile device. Finally, the third block is made up of an optional body, which begins after that first line break at the end of our header block. And since the request we're looking at is a GET request, we actually don't have a body. But suppose if the web server accepted a form submission to look up order status instead. In that case, the post request using the post request method might include a body that looks like this. Here we've added a body with the name of the form input where we entered our order ID and the value of that input, 123 in this case. Note that we also changed our request target to be just orders since we're providing the order ID in the body instead of the URL. We also added a couple of new headers, one content type, which tells the web server how the data in our body is encoded, and a content length header telling the web server the size of the body. And that's it. I've seen HTTP requests represented this way before, but like I always thought it was some kind of shorthand or human-friendly representation of what was going on under the hood. I didn't realize I was looking at the HTTP protocol itself. Basically, sending the contents of that file to the IP address on our web server using a transport protocol is literally the same thing as typing the web server's IP address, port, and target resource into the browser. And that's because HTTP is what's considered to be an application layer protocol. It's like the language that the web servers and the client speak. If any other application protocol other than HTTP is sent, to our web server, it won't know how to handle it. Let's go back to Jim and Jane for a minute to kind of clarify this idea. Imagine that Jim, who, if you recall, is available at extension 8000, only speaks French. Meanwhile, let's imagine Jane, who again is available at extension 8001, only speaks German. If you as a German speaker dial extension 8000, Jim won't have any idea what you're saying because he only speaks French. He won't even be able to help you with your request. He won't know that you're even making a request. Let's illustrate this point by starting Jim's web server again on port 8000, but instead of starting Jane's web server on port 8001, we'll start an FTP server on port 8001 instead. Now, FTP stands for File Transfer Protocol, and as the name suggests, FTP servers were typically used to transfer files in the dark ages before you had services like Dropbox. Now, if you start an FTP server, it begins listening for requests sent in the File Transfer Protocol, which is a different language than the hypertext transfer protocol that web servers and web browsers speak. Now that our FTP server is up and running on port 8001, let's go ahead and navigate our browser to that port on our local host, and we can see that we get this error message. This page isn't working. 127.0.0.1 sent an invalid response. Error, invalid HTTP response. Now, basically what happened is the web browser sent an HTTP request to the FTP server. And then the FTP server didn't understand the request and returned a response indicating as much in the FTP language, which our browser that only speaks HTTP didn't understand either. And thus our browser is giving us this invalid HTTP response error. So now we know that HTTP is the language web browsers and web servers speak. But how is the HTTP request actually being sent to the web server? And I've kind of intentionally glossed over this until now while we've looked at what a valid HTTP request looks like, but we have to send it to the web server somehow. You see, HTTP and FTP are what's known as application layer protocols, meaning they both run on top of an underlying communications or transport layer protocol. Let's go back to Jim and Jane for a second. Think about how they speak different languages, French and German, in our latest hypothetical, but both of their voices are carried over the telephone line. German and French are the application protocol, like HTTP and FTP, but the phone line that's carrying their voice, that's the transport layer, which in the web server world is the transmission control protocol, or TCP. Now, I'm not going to get too deep into the inner workings of TCP. It's really beyond anything you need to know to get started with building web applications, but just know that TCP at a very simple level breaks data up into packets. Then using handshake and confirmations, it ensures that every packet is successfully received by the recipient, and the recipient knows the order of each packet for reassembly. Now that we know how a request is sent to the web server, the next thing that happens is that the web server returns a response. Again, just like our browser sent our request in the HTTP language, so too does the web server return an HTTP-based response. And just like our request, an HTTP response is just text data, again, separated into the same three blocks. Again, we have the start line, which for a response is sometimes referred to as the status line. It contains our HTTP version and an HTTP status code. Here, the response contains a status code 200, which is kind of the generic response for a successful HTTP request. I'm pretty sure I could easily do a 20-minute video just on HTTP status code. So make sure that you subscribe if you're interested in seeing that video. But back to the request. Below that first line, just like in our HTTP request, we have multiple lines of headers defined again as key value pairs. And just like the request, again, headers are enumerated beginning on line 2 and are bounded by the first line break that we encounter. One of the important headers in this example response is the content type, which here is text/HTML, which lets our browser know to expect a text file, text content, and that the text content will be HTML, hypertext markup language, aka a web page, in the body of the response. And moving down to the body, sure enough, as promised by our content type header, our body contains HTML content. Here the HTML, just a simple header tag containing the text hello world. Now, if this were an API response, the content type might instead say application JSON, in which case the response body would contain some JSON data for our application to consume. And taking it one step further, if the resource we were requesting was an image, the content type might be image/JPEG, and the body would contain the binary contents of an image file. The main takeaway here is that the content returned by a web server is not limited to just web pages. The body of an HTTP response can contain all kinds of things like images and PDF documents and JavaScript code or web fonts. In fact, the video you're watching right now was returned piecemeal in bodies of a bunch of HTTP responses sent by YouTube's web servers to the web browser or your YouTube app. All right, now this kind of transitions us to the last piece of what a web server does. Now we've looked at the HTTP response in the abstract, but let's talk a bit about how a web server decides what to respond with. And I mean that in the practical sense. If I request an image resource and the web server returns it, where's that web server getting the image from? How do we actually set this up in the real world? Determining which resource to return is often referred to as routing, which is really just the practice of connecting a request with the requested resource, the content that's being requested. And for our purposes, it's helpful to think about routing as being separated into two distinct categories. There's static routing, and then there's dynamic routing. Now, static routing is just the web server serving actual files out of the folder. Just like you have a folder on your desktop that you can navigate to and open various files. You can open an image of a cat, you can open a text file. Similarly, you can point the web server to a directory on the file system and tell the web server to return anything that's requested. In fact, let's do that now. We'll open this folder, and as you can see, I've got an image file called cat.jpg, which, as you might have guessed, just a picture of a cat, and two HTML files, index.html and hello.html. And if we take a look at those files, they're very simple HTML files that just contain their respective file names in an H1 tag. So let's go ahead and start up a web server listening on port 8000 inside of this folder. Now, if we navigate to 127.0.0.1/cat.jpg, our web server returns the image of the cat. And if we navigate to the root at 127.0.0.1, we get the default index.html file's contents. And finally, if we add a /hello.html to the root, then we get the hello.html contents. And if we navigate to somewhere that doesn't exist in the target folder, then we get a 404 status or file not found. And that's because the file does not exist on the web server. Now, static HTML websites like this, they can be really cheap and performant to host since they require very little resources. A static website, the web server is just taking a file that already exists, returning the contents in the body of the response, something that web servers are highly optimized for. And to that end, you can host static sites completely free using something like GitHub Pages, or mostly free with an Amazon S3 bucket, and handle huge spikes in traffic, hundreds of thousands of visitors in case one of your blog posts makes it to the front page of Hacker News or Reddit, without any slowness or downtime for only a few cents a month. But what about situations where the content that exists at a particular resource changes dynamically? Think about a My Profile type page that changes depending on who the logged in user is. Or imagine an e-commerce web page where you can check your order status. Surely you wouldn't generate a static HTML page for every single order in your system and then have to switch out those pages whenever an order status changes from processing to shipped to delivered. Of course not. Instead, you'd save that info to a database and serve the contents of that database dynamically. In practice, this usually means configuring your web server to route all requests to a single file or executable, which serves as an entry point for your web application. And that web application could be created using programming languages like JavaScript, PHP, Python, Ruby, and it would evaluate the HTTP request and then dynamically prepare a response depending on the requested resource. Opening up the HTTP request we looked at before, we see it's requesting the resource for order ID 123. And if you sent that to a web application, it would search the database for order 123 and return the status. Now, I happen to have a very simple example of a dynamic website that does exactly that. Okay, so now we're in this dynamic folder, and I'm going to start a web server on port 8000. And if we navigate over and we go to localhost 8000 orders, and we'll check order ID of 1, you can see that it comes back, says order 1's been delivered, and gives us a tracking number. Let's go ahead and check the status of order 2. We can see that order 2 has been shipped, and again, it provides us with the tracking number. One more time, let's go ahead and check a order status of order 3. We can see that it's processing, and we don't have a tracking number yet. Let's see if there's an order status for 4. We check order status for 4, and it's the same, processing, and there is no tracking number. Let's go ahead and check and see if there's an order status for 5. Here we get this page cannot be found, an error of 404 was given. So that means there is no order ID number 5 in our system here. Let's go ahead and jump into the code and see how I set this up. Now, I wanted to keep this as simple as possible, so you can see this whole dynamic website consists of just a PHP file. It's not importing any libraries at all, no composer files. It's just raw PHP standard library. And you can see that the entire dynamic web application is only 45 lines long. And we also have a SQLite database. And if we jump into the contents of that real quick, you can see that it has one table. And in that table, there's columns of ID, status, and tracking number. So let's jump into this index.php and see how it's dynamically routing our request in order to return our order status. We first are getting our order ID from the route. Here, we're using this parse URL helper in order to get the path out of that request URI. And then we're passing it to this regex method, which basically says, look for, or this regex pattern says, look for orders followed by a slash and then any digit. And then it takes that regex pattern and it does this purex match. And if no matches are found, then it returns this not found function or calls this not found function that sets the header to 404 and then just exits right there. But if this path variable does match this regex, so it's like order/1 or order/2, then it returns that match as the order ID. So you basically get this integer back. You can see it's saying return an integer from this function, and that gets stored into this order ID variable. That order ID then gets passed to our get order status from database function. And we can see how that works down here. Basically, it takes that order ID as a property. It creates a new connection to our SQLite database. Then it creates this SQL statement that says select all from orders where ID equals question mark. Then it binds the order ID. And then here it fetches the first result as a associative array, stores it in this result variable. So if the order ID is not found, this result variable is null. And then again, it returns this not found function or calls this not found function that sets the response status code to 404 and then exits. But if a request is found, it's being returned as an associative array. So that's going to contain the ID, the status, and the tracking number if it's not null. And it's going to return all that back up here and store it in the order details variable. Finally, we call the print HTML function and we pass it that order details array that we got back from the database. And if we scroll down to the print HTML function, you can see it takes that order, those order details, that array of order details, and it just says print, and it defines basic hypertext markup language. You've got the opening HTML tag, the body tag, and then you've got an H1 tag where you're reaching in and getting the order ID and the order status, and then you're getting the tracking number and returning it right here. So again, going back, if we go to orders like 1, it's reaching into the database, getting the content for order number 1, and returning it to the user. So that's a really high-level overview of what a web server does. As always with this channel, I'm just trying to introduce you to these concepts so when you encounter them later, you have enough familiarity to Google your way to a better understanding, something that all software developers do. If you enjoy this kind of content, please consider subscribing. Thank you so much for watching, and I'll see you guys next time.
All right, so right there is probably a good spot to stop and take our first break. And let's come back in about 8 minutes, so at 9:10, and then we'll continue and we'll look at IIS and then Nginx, and then we'll get into lab a little bit early today. So let's come back at 9:10 and then we'll keep going. All right.
Professor.
Yes.
I'm having internet issues right now. I'm on my phone using my phone data.
Okay.
I'm kind of having internet issues, so I wouldn't be able to follow through the lab. I called my internet provider. They said that, but my internet won't be up until maybe 10:30 or even later.
Okay. Well, just follow along with your phone for now, and then for the lab time, hopefully you'll be back online. If not, you can do the lab and when your internet's available. Okay.
Oh, okay.
And I created video, all that stuff's available for you. So.
Okay,
Right.
I just want to ask, because if it's not up by 10:30, then I might be moving my whole setup to my sister's until I can get it working.
Okay. Yeah, no problem, Luis. All right. I'll see you guys at
Okay.
at
Thank you.
9:10. You're welcome. All right. All right. So welcome back. Let's get back into this. I'm going to share my screen again. Let me do that. And we'll go to what is IIS. So this is link 2 on the week 7 lecture material.
Your own website and host.
Let me get this the way I want it.
Atera includes everything MSPs and IT pros need in one.
Hi everyone, I am Hassan from Educate, and you're watching Learn Web Server IIS in 30 minutes. In this video or lecture, we will learn the basics of IIS. We will go over what's IIS, how it works. We're going to install it on both Windows 10 client and Windows Server. We'll go and host our website. So we'll see how to work with bindings and application tools and much, much more. When you finish this video, you will be able to start working with IIS and start hosting your own website. If you're ready, let's start together. But before, please, don't forget to subscribe to our channel and like the videos so you can get all the updates when I release new lectures and videos. Thank you, and let's start. So what is IIS or Internet Information Services? Let's make things simple by looking over this example. Let's say we have a web application or a website. It can be static or dynamic like ASP.NET or PHP. And now we need to make it available all over the world on the internet. So now, to bring the website online, obviously we have to host it in a web server. And whenever a user requests the website by trying to type its name in a web browser address, the request will be resolved by the worldwide DNS servers in order to acquire the server IP address. And then it will route the user request to the target web server. Then the web server is responsible for processing the request and replying back to the user on a form of HTML pages using HTTPS or HTTP protocol. Wait a little bit. What's the relation between IIS and what I am talking about? Simply, IIS is a Windows component that works as a web server, and it's responsible for hosting both web and FTP sites on your server. Very nice. Now, let's install IIS on both Windows 10 and Windows Server 2012 R2. Let's start with Windows 10. It's very simple. Let's open the control panel, open Programs, then click on Turn Windows Features on or off, and here just check Internet Information Services, and click OK. Very simple. Let's wait a little bit for IIS to be installed. Now click Close. Very nice. Let's open the Start menu now and search for IIS. Here it is. Open it, and this is the IIS Management Console. This where most our work will be in. Now let's install IIS on Windows Server 2012 R2. It's very simple. Just open Server Manager by clicking on the shortcut icon in the taskbar, or just open the Start menu and click on the Server Manager. Now click on Manage, Add Roles and Features. To add a role, select role-based or feature-based installation and click Next. Here's my server I'm installing on. If you are managing a remote server, then be sure to select the appropriate server. Now in the roles list, go down and check Web Server IIS role. It will ask you to add some features related to IIS. Just click Add Features. Now just continue to the Role Service tab. And here we have a list of all services related to IIS role. I'm going to install just some of the main features to work with the core of the IIS. Just check ASP.NET 3.5 and 4.5.
When we do our install, we're just going to leave all the default features. So just next for us. He's eliminating some because he wants it specific for his environment.
Also, I will select the management service, allows you to manage the server remotely. And I think this, later on, we will install each service as needed. Now click Next. And here there is a small thing I want to mention, which is related to Windows Server 2012 and Windows 8. When you try to add .NET Framework 3.5, the installation will ask you for the installation directory, which is located on the Windows installation disk or ISO file. So now just click on Specify an alternate source path and open your installation disk or ISO file. Then go to the sources folder, then SXS, and copy this directory to the installation wizard. Okay, I think this is simple now. Let's click Install and begin the installation. All right, awesome. Here we are, the installation finished. Let's close it. And as we can see now, we have an IS role is added to our main server manager dashboard in the left. Now we can click on Tools, open Internet Information Services Manager here. And here we are. This is the main console. And here is the site section. We have a default website that is added automatically. Let's click on Browse Tested. Very nice. This is the default website is working and everything is fine. Hi friends, here I am again. Just I want to mention something that this video is a part or a small part of my web server IS master course on Udemy. If you
Atera includes everything MSPs and IT pros need in one.
are interested in learning more about IS, about advanced options, about securing IS, about high availability, about three case scenarios, and much, much, much more, then you can find my course link in the description below if you want. Thank you, and let's continue our course. Before going deep in the course, I want to talk about a small tool from Microsoft that's very important when it comes to managing IS web server. It is the Web Platform Installer tool. Let's go directly into the topic and start by installing the tool to see how it works. Just open your web browser and search for Web Platform Installer. You'll find the first link on Google for Microsoft. Just open the link. And here in my case, it's version 5.0, the latest version. Click on free download and save the file and continue the installation. It's very basic. Launch the file, run, and here we are. There's the tool installed and ready to be used. As you can see here, we have products, we have applications. In the products, we have server products, frameworks, we have databases and tools, and so on. Basically, what this tool does, it allows you to install some components and models related to IIS and facilitate the work with these components in updating, installing, and so on. So as you can see here, we have in applications, PHP, we have Python, we have Windows SDKs, related to Azure. Also, we have WordPress, Joomla, Moodle, and so on. We have a lot of applications and models that we can use simply with our IIS server. Let's do an example. I will search for URL rewrite, which is a very important tool in IIS. Don't worry about it now. Just I'm testing the Web Platform Installer tool. Just select it and click install. It will show you the prerequisites and what will happen. Just click accept and the installation will begin and everything will be done by the Web Platform tool. You don't worry about anything. Everything will be configured and installed using the tool. And this is what it makes it very powerful. All right, now let's start by creating our first website and see how to host it in the IIS Manager. Let's open IIS, simply click on the Server Manager icon and click on Tools, then Internet Information Services Manager. If you remember here, we have the default website in the site section, and we opened it using the browser. It's localhost. Just write localhost in your browser address, and this is our default website. So now let's create our own custom website. Just right-click on site and click add a website. All right, as you can see, we have to set the site name. The site name is the name that will appear in the IIS Manager. As a best practice, set this site name as your domain name, so it will be easier for management, especially if you have multiple websites on your server. So set a website name. I will set website1.com. And the next thing we have to do is to set the physical path. Simply, the physical path is where your website files are located. Here I will select my sample website in the init.pub folder directory in the C drive, which is the default path that comes with the web server manager. Select my path, web server 1. Let's see where this is located. Open the C drive, init.pub, and here we have website 1, and here is the website. Let's open the index page. It's a sample HTML static website. Let's open it, and here we are. This is my sample website. Now, the second option we have to set is the bindings. Bindings are very, very important. I will explain it in a little bit. But for now, binding is the method that the IIS uses to identify websites upon request. So when a user requests a certain website using its host name or its IP address, the binding is responsible for identifying and getting the appropriate website upon that request. In the bindings, we have four things to set. The first one is the protocol type. We can set between HTTP and HTTPS if you are using SSL certificate for securing your website. We'll talk about this later. The second thing that's set is the IP address. You can set your website to open using a specific IP address or using any IP address on your server. I will keep it as all are assigned now. And the third thing you have to set is the port number. As you know, HTTP by default works on port 80. So it's not recommended to change this port except if you are using a private application that you want to secure with a certain port number. It's up to you. And now we have the host name. Simply, it is the domain name of your website or your subdomain. In my case, I will be using localhost since I am working with a lab environment just to test now our website. And here we are. So here we are, we create our new website, website1.com. Let's open it, click on browse, and oops, we have opened the local host and the default website open and not our new website. What happened? Simply, this happens because both websites have the same bindings. We have localhost as a domain name or as a host name for both websites. So to fix this, we have to edit the bindings. So edit the bindings of our website, and we have to change the host name to a certain canonical name for us. Since this is a lab and we don't have a public domain name to use, I will do a simple trick using the hosts file. All right, to do this, let's open Notepad as administrator. So open the start menu, go to Notepad, and be sure to right click and run as administrator. Now click File and let's open the host file. Navigate to C, Windows, System32, Drivers, etc folder. Then click on Show All Files and here is the host file. Open it and here we are. Now let's add a record in this host file. I will say 127.0.0.1, which is the local address. Let's map it to our domain name, website1.com. Simply, what this file is, it somehow acts as a local DNS for your Windows server. So it can map an IP address to your domain name. In this way, when we map our domain to the local address, when the browser tries to access this domain name, it thinks that this domain is hosted locally. So it navigates to your local server to open it. I hope the idea is simple. Now just save the file and let's close it. Right, website1.com in the bindings host name, and let's now try to open our website. And very, very nice. As you can see, we opened website1.com in our browser and everything is fine. So now we have two websites, our default website with localhost, host name binding, and our hosted website, website1.com. You can simply right-click on the website and click Explore to open the physical directory and see your files. So this is it, and this is how you can create your website, your own website, and host it inside the IIS Server Manager. All right, everyone. I hope you're enjoying my course and everything is fine. Okay, let's consider we have a user requesting a certain website called www.web1.com. So whenever a user requests a website, the worldwide DNS servers will get the request and retarget it to the appropriate server on the internet. And this is done using the server's IP. So now we have selected the appropriate server, which is hosting the website. Very nice. Now, inside this web server, we may have multiple websites hosted. So how the server will know which website the user is requesting? Very simple. This is done using the website bindings. So here it comes, the roles of bindings. As I showed you before, we can use multiple parameters to identify or differentiate between websites on the same server. This can be by the domain name or the host name, like in our case, where we are using web1.com as the host name, or maybe using the IP address, or even the port number. We will see this in a little bit. Also, the IIS will know if the connection is secured using the HTTPS protocol by looking at the configuration of the bindings for this website. I hope you got the point and how the bindings works in general. Let's now go back to our server to show you how to use these bindings and to show different scenarios. So first, let's delete the default website since we are not going to use it again in our course. We will work with our custom website. Now we have website1.com. Let's test it, open the browser, website1.com. Very, very nice. Everything is fine. Now let's right-click on the website and click on Edit Bindings. Select our binding and click Edit. Here we have set the website to bind to a certain host name. Let's remove it now and select an IP address. This is the default IP in our server, and click OK and close this dialog. Now open the browser and let's type the IP address in the address bar. As you can see now, our website is working but using the IP address and not the host name. Okay. Let's now do another thing. Open the bindings again, and now I will change the port number and set it to 81. Now, let's refresh our website using the same IP address, but the website will fail to load. Why is that? Simply because we changed the port to 81 in the binding, and by default, the web browser is using port 80 to work with the HTTP protocol. So obviously, it will fail to load the website. So now, if we want to fix this, let's open the website, but now just add a colon after the IP address and add 81 as a port number. And awesome, that's it. Now our website is working under port 81. I hope you got the point and everything is clear. When we create a new website in IIS, as you can see here in the wizard, automatically IIS will create an application pool for the website to work with. So what is an application pool? To make things simple, whenever you have a website in your web server, the website processing and execution will be done using a worker processor, which is a part of the application pool. So for that, the application pool will automatically be created when you create a website. You can think of it as a logical container where the website will work inside. Now, each website can have its own application pool, or you can create multiple websites that use the same application pool. All right, so here we are again on our server. We can find the list of application pools here by clicking on the application pools icon on the left. And here is the list of application pools on your server. Here, as you can see, we have website 1, website 2 application pools, each associated with its own website. Now, to add a new application pool, simply right-click here and click on Add Application Pool. Now, set the name of the application pool you want. And here we have two options, the framework and the pipeline mode. In general, if your application is using .NET, then select the appropriate framework from the list. If it's a PHP website or a website that is not using .NET, then you can use non-managed code. And the pipeline mode, for now, set it to integrated and go for it. The classic mode is used in IIS 6 for older websites. Now we can go to the advanced settings of any website and change the application pool you want to run your website on it. Very simple. Now let's see this. Open your web browser and let's open my website, website1.com. Now open Task Manager and go to the Details section. And here, if we go down, you will see the WPW process. This is the process of the worker processor that is associated with this website application pool. You can see the username is website1.com, which is the identity of the website the application pool is running with. Let's now again open website2.com. And as you can see, we have another process created for this website with website2.com identity. So this, what I'm talking about is the processor or the worker processor that is associated with a certain website. Now, if these two websites were working with the same application pool, then we have one process only for both. If you want to monitor and see the worker processes that are working inside your IIS manager, just click on the server node and click on worker processors, and you will find all the worker processors running on the server. We can see the CPU usage, the process ID, the state, the private and the virtual memory, and so on. All right. Now, what is the main reasons for using application pools? As I mentioned before, we can create multiple websites for the same application pool. And we can create multiple application pools on the same server. This architecture will provide isolation for our websites. So isolation is the main reason for using application pools. So now we can use different frameworks like framework 2 in the first application pool and framework 4 for the other one. Or we can implement different security aspects or maybe apply different settings that corresponds to each group of websites. So we can have full isolation between websites. So if application pool, as an example, recycles, the other application pool websites will not be affected. Other thing you have to know, let's take this example. We have a website which has two folders containing two sections of or pages of your website. Let's say the services pages and the card pages. What you have to know is that you can divide a certain website into multiple application pools, like moving the services folder to an application pool and the card to other application pools, like application pool 1 and application pool 2 in this example. In this way, if you have a part of your website that has some bugs, or maybe you are testing something new that may contain some bugs or may cause the application pool to reboot, then in this way, the second part of your website will not be affected. And this is very important if you are testing something, as I mentioned. All right, now I want to show you how to install and configure FTP server on your web server in order to access your files and websites using FTP. First thing you have to do is navigate to Server Manager and be sure to install the FTP server feature or role. Click on Manage, Amazon Features, navigate to the server roles, navigate down to Web Server, and check FTP server. Standard and check FTP accessibility also. Click on Next, Next, Install. Just wait a moment. Now it's finished. Let's open again. Server Manager. Click on the server node. Now in the sites, just right click, and now we can have the capability to add FTP site. Let's add one. Let's name it Web1 FTP as an example. Select the physical path. I will say CNET58 website 1 as an example. Click OK. Now click on Next. You can select the binding as in the website. You can select any IP address, and the port will be by default 21. That's used by FTP. So if you are using FTP on your server, please be sure to allow also port 21 in your firewall. You can select the SSL to be used also, then it will be FTP. Now I will use no SSL, and I will start the FTP site. Let's click on Next. Here you can select the authentication. You can set anonymous. Of course, you don't want to use anonymous authentication with FTP so anyone can access your data. Let's use the basic authentication and select the users you want. You can select specified users. Let's say, as an example, admin, and we select the permission to read and write, or maybe only read. It's up to your architecture. Click finish. Now you have this WebFTP can be accessed remotely using an FTP client. All right, let's test our FTP now. Just open your browser and search for FTP client, and you'll have a list of FTP clients you can download. I am working with FileZilla. Just download FileZilla client. Click on download and download the software and install it. It's very simple. After installing the software, this FileZilla client, just open it, and now I will say localhost, since I'm working locally here. Of course, here you set the IP of the server or the name of the server, the domain name. Just enter the username, which is admin, and set the password, which is the Windows administrator password. And we use port 21, and let's click on quick connect. As you can see, this is our website here is listed, and this is our file. FTP will help you if you want to update your data, your files on your website from directly synchronized from your local machine, which is the developer machine, to the target website. You can synchronize directly by uploading, downloading files. As you can see, upload files and downloading files and so on. So this is how you can configure FTP service on your web server to access your website remotely using FTP clients.
Okay, before I end this video, I want to show you how to install WordPress on your IIS server, and I will show you the power of the web platform installer too. Just open your server node and click on web platform installer that we installed in the last lectures. Just double click to open it and wait a little bit for it to load. All right, now simply search for WordPress. And here it is. This is the WordPress application. Click on add and simply click install. Now it will ask you for the prerequisites. It says read MySQL and is not installed. Just select the password of the root and everything will be configured automatically. This is the root password of MySQL. Just put it here and click continue. And it will show you that it will install WordPress with MySQL for Windows. Just click I accept. And now just wait for the installation to finish. It's very simple. As you can see, this is the power of the web platform installer. If you want to do this manually, you have to download the MySQL connectors, MySQL SDKs, MySQL for Windows, install them and get the WordPress from its website, install them and configure them and so on. This will be done automatically using the web platform installer. For that, it's very important to install it on your IIS server. Now just wait a little bit for the installation to finish. Wonderful. The installation is finished and now we are in the configuration section. Just select here new website and give it a website name. Let's say my WordPress. And this is the website name. Let's say WordPress. Let's say WP. And let's set the physical path to my computer, C drive, IFPub, make new folder here, and let's say WordPress. And now let's click OK. And set the bindings here. The IP address is $4 and port 80. And let's name the host name as www.mywp.com. So this is my host name. I will put this in the host file as I showed you in the lecture where we installed our first website. Now just open Notepad.
Having a career gave me an opportunity to grow as a person and help others grow to be successful. If you give someone an opportunity, their life will get better.
Run as administrator, and let's open the host file. It's in the C drive, Windows, System32, drivers, etc. Click all files and use the host file. And now I will get this host name and paste it down here, 127.0.0.1. And here we are. Let's save it and close this and click continue. And here we have to set some authentication keys that WordPress uses. You can use any phrases for now. Let's say I will put this phrase 1, 3. Scroll up, press, and let's copy it. Copy this here and here. Just copy the security keys, source, and click on continue. And the configuration will now start. As you can see, the installation is very simple using the web platform installer. Let's wait a little bit now. And awesome. As you can see, it shows you the password of your database, the username, and the password. You can save these so you can use them later. Just put them somewhere else on your notepad or any file and click on finish. Very nice. As you can see, the browser will open automatically, and this is my website. mywp.com is opened automatically, and this is the WordPress installation. Click continue. And the site title, the username, and so on. You can continue the installation and start using WordPress using your IIS server. Welcome again. I hope you enjoyed this mini course and you got some benefit, and you can now start working with Web Server IIS. As I mentioned before, if you are interested in learning more about IIS and go more in details, please refer to the link in the description, and I will be with you in the mastery course. Thank you for following. If you like the video, don't forget.
All right, so that's the IIS. That's a really big overview. We're just going to do the default website and then one virtual host today in our lab. And where he showed he was editing the host file on his server because he was accessing the websites from his server, we're actually going to edit the host file on our Windows 10 client 1 machine. So, but the concept is exactly the same. All right, any questions on the IIS and how to work with the Windows server? It's pretty straightforward, pretty basic. And you should have no problem getting that to that part there. All right, thanks, Frankie. At least I know you're listening. All right, there we go. All right, so let me share my screen again, and we'll watch a video on Nginx. So again, this is from YouTube.
Internet Information Service.
I'm gonna put that back there. Turn on the captioning. So this is just the fundamentals of Nginx, which is the other browser platform we're going to use today.
Sahiti on behalf of Edureka, and I welcome you to this session on Nginx tutorial. Since guys, Nginx is quite a vast topic to understand, in this session we'll mainly focus on all the basic knowledge that you need to get started with Nginx. So now, without wasting any further time, let me take you to the topics for today's session. So we'll start this session by understanding what is a web server, and then we'll get into what exactly is Nginx. Once you understand Nginx, I'll tell you about the Nginx architecture and the reasons on why you should learn Nginx or why you should use Nginx. And finally, I'll end this session by showing you how to install Nginx and then deploy an application on the web server, right? So I hope the agenda is clear to you guys. Okay, so that's great. So now let's get started. Now, when you type https://google.com in your browser, what do you observe? In few seconds that your Google homepage appears in front of your screen, right? But have you ever wondered, in the process of you typing the URL, pressing enter, and the page appearing, a lot of things happens, guys. Well, what happens is a request is initiated by your browser leaving your local area network, and then that particular request traverses to the global area network till it reaches one of the computers, which is basically assigned to serve your Google's homepage. Now, then this particular computer in return initiates a response containing all the contents of the page. So for example, if you want to search google.com/edureka or slash any other thing or any other page, it will basically initiate a response containing the contents of the page, right? So basically, the response takes the similar route through the global area network till it reaches the local area network and finally to your computer browser, right? So what have you observed over here? When you type in a URL, a request is basically generated to a computer connecting those web pages, right? So now when that computer initiates a response containing the web pages that you've requested for, these web pages basically travel through the global area network and reach your local area network and finally to your browser. So now the computer which is basically serving you with the web page is nothing but the web server, guys. So when I say web server, I mainly mean the computer that is serving you the web pages. So this computer is basically known as a web server, right? So I hope I'm clear with this point. So now let me tell you what exactly a web server is. Well, web servers are basically computers which deliver the requested web pages. So basically every web server has an IP address and a domain name. All right, so now let me just explain you this point. Now, so for example, suppose you want to search https:/edureka.co/blog, right? So suppose you basically want to search for our blog's homepage. What would you do? You would basically type in this URL on your browser, right? Now, what happens is as soon as you type your URL, a request is generated traveling to your local area network, and the request goes to a web server whose domain name is edureka.co. Now, what this web server does is it fetches the page with the name blog. So basically, that is the index page that we want to fetch, right? That is /blog. So the page with the name blog is fetched. And then this particular web server again sends the response to the users to the global area network again, and then it reaches to your browser. So basically, whenever you search for /blog or /community or anything else, what happens is it comes to a web server whose domain name is edureka.co. And then your index page, basically whatever you're searching for is fetched. And then that particular page has been sent to your browser, right? So basically, this particular computer is said to be web server. So guys, now that you've understood web server, let me just tell you one more point over here. What happens is when you use a web server, you need applications or software applications which can make your computer a web server, right? So basically any computer can become a web server. So if you want to make your computer web server, you have to install server software and connect the machine to the internet, which is basically the global area network. So in the market, there are various web server software such as XAMPP, Apache, Nginx, Tornado, Caddy, and Microsoft Internet Information Services, right? So guys, since this session is basically focusing on Nginx, we'll be mainly focusing on Nginx server only. So now let me just tell you what exactly is Nginx. Well, Nginx is an open source software. So it's basically a web server used for reverse proxying, caching, and the load balancing. So Nginx basically also provides your HTTP server capabilities and is mainly designed for maximum performance stability. Apart from that, let me also tell you that it also provides functions for a proxy server for an email such as IMAP, POP3, and SMTP, and also uses a non-threaded and event-driven architecture. So if I have to define Nginx for you, or if you have to understand Nginx, in simple terms, it's basically a web server by which you can make sure that your page load time is reduced. So for example, if you're working on an enterprise, you need to make sure that the customers coming to your web page or the customers searching for your web pages do not have to wait a long time for your page to load, right? So when you use Nginx or when you start using Nginx and you make sure that your applications are getting deployed through Nginx server, you'll make sure that your page load time is definitely reduced, right? So now that you've got an idea of Nginx, let me just tell you the architecture of Nginx, right? So Nginx mainly uses a master-slave architecture, guys. So basically this master-slave architecture supports the event-driven, asynchronous, and the non-blocking model, right? So now I know by looking at this definition, you've just not understood anything, like what exactly is event-driven, what exactly is asynchronous, and what exactly is non-blocking model. Don't worry, I'll tell you when we get into the architecture. So now, as all of us know, traditional processes or thread-based models of handling concurrent connections involve handling each and every connection with a separate process of thread and blocking on the network or input or output operations, right? So basically, when you have a process thread model, what happens is each and every separate process basically can be used for an input, or you can generate a separate thread for each and every connection that is required, right? Now, depending on the application, it can be very inefficient in terms of the memory and CPU consumption. Just imagine you had to do this for a large enterprise. So when you're looking for a large enterprise with so much of web pages and so much of data on each of its web pages, it can be very inefficient in terms of memory and CPU consumption, right? So spawning a separate process or a thread basically requires preparation of a new runtime environment, including allocation of heap and stack memory and also the creation of new execution context. Not only this, guys, but let me also tell you that additional CPU time is also spent creating these items, which can eventually also lead to poor performance due to thread crashing or excessive context switching, right? Now, to avoid such kind of complications, Nginx put its master slave architecture that you can see on the screen. So Nginx mainly focused on the ongoing development of the advanced event-based mechanisms in the numerous numbers of operating systems. So Nginx uses multiplexing and event notifications heavily and dedicates the specific tasks to separate processes. So for example, if you have 10 tasks, then you can have these 10 tasks to be dedicated to 10 different processes, right? So apart from this, connections are also processed in highly efficient run loop in a limited number of single thread processes called workers. So if you observe on your screen, there are mainly three workers that I've mentioned over here, right? Within each of these three workers, Nginx can handle many thousands of concurrent connections and requests per second. Now, what happens over here is Nginx doesn't spawn a process or a thread for every connection. Instead, what happens is worker processes accept new requests from a shared listen socket and execute a highly efficient run loop inside each worker to process thousands of connections per worker, right? So I hope that you've understood what worker does is. What worker processes basically do is they accept new requests from a shared listen socket and execute a highly efficient run loop inside each worker process to process thousands of requests. So every worker can process thousands of requests. Now, apart from that, if you observe in the diagram, you have a master, right? So according to the Nginx architecture, there's basically a single master and there are many several worker processes. So there are also a couple of special purposes processes like the proxy cache that you can see on the screen, like it has a cache loader and a cache manager, right? So now before I get into the caching part of Nginx, let me just tell you about the master. So the master process is basically responsible for reading and validating configuration. So when I say reading and validating configuration, I mean that master is responsible for creating binding and crossing sockets. It is also responsible for starting, terminating, and maintaining the configured number of worker processes. So suppose if you have 10 worker processes, it's not required that all the 10 worker processes would be running for 1,000 different separate processes, right? It can happen that few workers have less number of processes working and few workers have more number of processes working, right? Not only this, but the master node is also responsible for reconfiguring without any service interaction. It also controls non-stop binary upgrades and reopening of the log files, and also compiles embedded Perl scripts, right? So the master processes is basically responsible for basically reading and validating the configuration. So when I say configuration in Nginx, everything is defined in a configuration file. So don't worry, I'll tell you how that is defined and what all you can define. So, but for now, let's come back to architecture. So guys, I hope that you've understood what the master process does. Now coming to the cache loader and the cache manager, the cache loader is mainly responsible for checking the on-disk cache items and populating Nginx in-memory database with the cache metadata. The cache loader process is responsible for checking the on-disk cache items and populating the Nginx in-memory database with the cache metadata. So the cache loader basically prepares Nginx instances to work with the files already stored on the disk in a specifically allocated directory structure. So basically it traverses the directories, checks cache content with the metadata, updates the relevant entries in shared memory, and then also exits when everything is clean and ready for use, right? Now, apart from this, there's also a cache manager, as I said. So cache manager is mostly responsible for cache expiration and invalidation. So it basically stays in the memory during a normal Nginx operation and is restarted by the master process in case of failure, right? So what's basically happening in caching is that, so for example, if you go to our edureka.co and then if you want to search for DevOps tutorial blog and then you get the page and then you read for it, right? Now, after a while, you come back to the same page. What happens is this page, when you want to retrieve back the same page, it doesn't go through the complete process of requesting and then a response and then the web server fetches the page and then a response is generated. Instead, what happens is this particular page, since you've already searched for it, may be stored in the cache, right? So what the cache loader and the cache manager do is they look into which page are you searching for and they send you back the page immediately. So it happens very quickly, guys. So guys, this was all about architecture. Let me just repeat it for you once again. So what happens is when you send a request, when you search for a web page or when you search for any item on the web, what happens is a HTTP request or an HTTPS request is generated to the Nginx architecture. Now, what the master does over here is it understands, it selects which worker has to take up this process and then dedicates this particular process to a specific worker. Now, then the worker works on it and then it fetches the web page from the web server and then it finally sends you back the response, right? So it's a very simple architecture, guys, if you look through above. So you just have to understand that, it works on event-driven model and it also works on asynchronous and non-blocking model. And it's a simple master-slave architecture, right? So it has one master and there are various worker nodes working for it. And then you can use these worker nodes for processing thousands of requests at a time, right? So I hope I'm clear with this point. All right, so that's great. So now that you've understood Nginx architecture, let's look into the reasons on why you should learn Nginx or why you should use Nginx, right? So you can use Nginx because of the features that you can see on the screen. It's basically very easy to install and maintain. When I say it's very easy to install and maintain, believe me, guys, it's just 3 steps or 4 steps to install Nginx onto your PC and make sure that you have a web server working for you. And it's very easy to maintain because you just need to type a single command to just restart or just maintain or stop the service, or you can do various other functionalities. Don't worry, I'll show you how you can install in the next part of the session. After that, let me also tell you that it reduces the wait time of the users. So as you know, in the session, I was telling you that you don't have to wait a lot of time when you use Nginx, right? So basically, even if you're fetching a web page which takes time to load and which is very heavy, by using Nginx server, you can make sure that your wait time is reduced. Not only this, but it also improves the performance. So when I say it improves performance, I mean that if you already have 2 or more web servers running in the same application, Nginx can accelerate performance by routing traffic to those web servers in a way that it enhances the overall speed, right? Not only this, but it also offers load balancing. So basically,
All right, I'm gonna stop that for just a little bit. And we'll take another break here, just so you're not completely asleep. I know some of these videos can be a little monotonous, but this is good stuff. I mean, she's doing a good job of explaining what is Nginx, which I really want to make sure we have a good understanding of that. So it's 10 o'clock. Let's stop, take about a 10-minute break, and then we'll come back and we'll watch the rest of this video. All right. All right, well, welcome back. And what we're going to do the rest of our time today is we'll finish this video, which will walk us through the installation of Nginx, and then we'll jump in the lab. So let's watch the rest of this video, and then we'll keep going with the lecture or the lab. Sorry about that. Let me share my screen. And we'll start up again.
Load balancer is device or a service that distributes the traffic load on 2 or more web servers, right? So this basically provides fault tolerance and increases performance also. Now, if you look into the market, there are various kinds of commercial hardware load balancers available in the market, which are actually very expensive and somewhat complex to set up in service. But when it comes to Nginx, Nginx can easily act as a robust load balancer that will cut off all your costs and also give you the needed load balance, right? So this is a very good point of Nginx that you need to take care of when you're using Nginx for a large enterprise. Moving on to the next feature. The next feature is that Nginx offers scalability. Apart from load balancing, Nginx also offers scalability. So as we all know that traditional web services like Apache and Internet Information Services can serve incoming requests without any problem until the number of concurrent requests reach a certain limit, right? Let's say 1,000. So whenever the number rises, the performance starts to degrade eventually. So that is because the way those servers were designed and also the model by which the server web requests, right? So basically, if you have to use such kind of servers for a large enterprise or for, let's say, you wanted to access 3,000 requests, right? You cannot use such servers for such kind of requests because, it will take a lot of CPU cores and also RAM and will not give you the intended results. So in such cases, if you use Nginx does not suffer from this problem and it can easily handle increasing number of concurrent requests, right? So suppose, if you have 20,000 requests that you want to access, right? you can definitely do it with Nginx. Apart from all these features, guys, the final feature is on-the-fly upgrades. So when I say on-the-fly upgrades, I mean that, Nginx is one of the very few systems that can be patched or upgraded without having to take a downtime and disrupt your businesses, right? So obviously you would never want to disrupt your business, right? So Nginx is one such software which can get upgraded without having to take any downtime for your enterprise, right? So if you have to look for the features, it's basically ease of installation and maintenance. It reduces the wait time for users. It improves performance. It improves load balancing. It offers scalability, and it also offers the on-the-fly upgrades, right? So guys, I hope that you've understood the features of Nginx. Now in Nginx, everything is based on configuration. So the core settings of Nginx are mainly configured in the Nginx config file. So the config file is basically structured into context. So when I say context, so there are mainly two types of contents that you can set up. That is the events context and the HTTP context, right? So basically this structure of configuration file enables you to, basically mention some advanced layering of your configuration, as each and every context can have nested context that inherit everything from the parent, but can also override a setting as needed, right? So don't worry, we'll look into it when we look into the hands-on part where I show you when we deploy an application. Now, apart from these two contexts, guys, there are various other things in the file that can be tweaked based on your needs. But Nginx is so simple to use that you can go along with it even with the default settings. So some of the most important pieces of the Nginx config file are the worker process, the worker connections, access log and error log, and the gzip. So basically, the worker process is basically a setting that defines the number of worker processes that Nginx will use. So since Nginx is a single threaded, this number could usually be equal to the number of CPU cores. Coming to the worker connections is the maximum number of simultaneous connections for each worker processes and tells our worker processes how many people can simultaneously be served by Nginx, right? So basically, the bigger it is, the more simultaneous users the Nginx will be able to serve. Coming to the third one, which is the access log and the error log. These are the files that Nginx will use to log any errors and access attempts. So these logs are generally reviewed for debugging and troubleshooting. Coming to the last setting, that is gzip. These are the settings for the gzip compression of Nginx responses. So enabling this one along with the various subsettings that by default are committed out will result in quite a big performance upgrade. So I hope I'm clear with these points. So basically, apart from the events context and the HTTP contents, you can also configure for your worker processes, worker connections, access log and error log, and the gzip, right? So guys, I hope that you've understood what Nginx is. Let's look into the next topic, that is basically how to install Nginx. So basically, to install Nginx, you need to follow these 4 steps, which are install Nginx, adjust the firewall, check your server, and then you can manage your Nginx process. So we'll start by installing Nginx. And once you see that your Nginx is installed, you have to adjust your firewall. Once you see that your firewall is also adjusted, you can check your server whether your server is running or not. And then once your server is running, it means that your server is up and running. And finally, you can manage the Nginx process, by which I mean that you can restart or you can stop, right? So I hope I'm clear. So now let's just shift back to our Ubuntu operating system so that I show you how you can install Nginx, right? All right, so I'll just shift back to my virtual machine. So the first step that you can do is you can just update your VM. So for that, you just can type in sudo apt get update. So just type in the password. So you can see that your VM is getting updated, right? So now you can see that your VM is updated. Now to install Nginx, you just have to type in sudo apt get install Nginx, right? So you can see that your Nginx is getting installed. So it just says, do you want to continue? You just type in yes, that's why. Right, so you can see that Nginx is getting installed. Let's wait for it to install. So now that it's installed, what you can simply do is you can just enable your firewall. So for that, you just have to type in sudo ufw enable, right? So when you type this command, you'll see that the firewall is active and is enabled on your system start, right? So you can just check if your Nginx is installed or not by checking for the version. So for that, you just have to type in nginx-v. So you can see that Nginx version 1.2.1 on Ubuntu has been installed, right? Now, since you've enabled your firewall, what you can do is you can list the application configurations that your firewall knows, right? So for that, you'll just type in sudo UFW app list. So when you type on this command, you'll see that you'll get all the available applications are Nginx full, Nginx HTTP, and Nginx HTTPS, right? So basically, this profile opens both port 80, that is basically the unencrypted web traffic, and also the port 443 that allows the encrypted traffic. The Nginx HTTP opens only port 80, that means it only allows the unencrypted traffic. And Nginx HTTPS opens the port 443 that allows basically the encrypted traffic, right? So what I'm going to do is I'm going to allow Nginx full so that both port 80 and 443 are allowed. So basically both the unencrypted traffic and the encrypted traffic are allowed. So for that, I'll just type in sudo UFW allow. In quotations, you just have to type in Nginx full, right? So you'll see that rule added for Nginx full. Now, similarly, if you just want to allow Nginx HTTP or Nginx HTTPS, you just have to type in the same command and mention HTTP and similarly HTTPS, right? So you can see that, based on whatever kind of traffic that you want to allow, you can make sure the application has been enabled, right? So now if you want to check if our applications are working or not, you can just check status. To check the status, you can just type in sudo UFW status. So when you check on the status, you can clearly see that, Nginx full, HTTP and HTTPS are allowed, right? So that means they're completely fine and they're working, right? Now, if you just want to check whether, where your Nginx server is working or not, you can just type in the command sudo system ctl status Nginx. All right, there's a typo error. That's my bad. I just missed an S over here. So you just have to mention sudo systemctl status Nginx. So when you mention this command, you'll see that, Nginx service, a high performance web server and a reverse proxy is active, right? So you'll clear words, you see that, it's active. And you can see that, there's a master process running for it. And you see the process ID and the main PID and the task, right? So that means the service is running perfectly, right? So guys, that's how you can install Nginx. So basically to install Nginx, you just have to use such few commands that, you have to first use the command of install Nginx and then you have to enable your firewall. Once you enable your firewall, you can just check what are applications are available for your firewall. And then you have to just make sure that, you make them active. Once they are active and running, you can check your system status, right? So I hope that, you've understood how to install Nginx on your system. So now let's move forward to the hands-on part. So in the hands-on part, what we're basically going to do is I'm going to deploy an application which is already stored in a folder on my virtual machine. So I'm going to deploy that application on my local host. Well, you can also do it on your remote host by just mentioning the ID, right? So I'm going to use this web server Nginx and then I'm going to deploy an application on it, right? So I hope I'm clear how we can do that. So let me just shift back and show you how we're going to do that. So first of all, let me just open the folder where I've mentioned that particular application. So I'll just clear my screen. So now I'll just go to the folder and show you. So let me just change to downloads. I think I've mentioned in downloads. And just list. All right. So we have a demo folder. So if you just go to the demo folder, and then if you list the files, you can see that, I have an index HTML file and a CSS file. So a single page website, which I'm going to deploy on the Nginx service, right? So now before I start with the hands-on part, let me just tell you that, I've installed curl. I've installed OpenSSH server and I've also installed the web editor. So basically I'm comfortable with web editor. So I've just installed that. I've installed curl to just in case fetch the website in the command line itself and the OpenSSH server. That is basically I've installed the OpenSSH server. So I hope I'm clear with the prerequisites. I've just installed these three and the Nginx service is also installed in my system that you just saw. So now what I'm going to do is I'm going to just come out of this directories. And now initially the first step that I'm going to do is I'm going to just copy all the files that are present in downloads that, just that demo file is present. So I'm going to copy this demo file into the var/www directory, right? So for that, you'll just type in the command sudo cp-r/home/edureka/downloads. And then I'll mention a dot so that, all are copied. And then I'll mention it, the destination directory. So the destination directory /var/www, right? So I mentioned this. Oh, I'm sorry. I mentioned an extra space over here. An extra space is not needed. So I'll just press on enter again. So let's just go to our /var/www to check whether, we've copied or not. So I'll just list. All right. So when I list, you can see that, our demo folder has come over here, right? So that means, we have copied our demo folder to /var/www directory. Now what you have to do is you basically have to point your domain name to your new server, right? So what I mean by that is your domain name needs to point to your new server, right? So basically you have to create a record in your hosting provider's DNS settings by pointing your domain name, let's say, sample.com to the server IP address. So let's say I consider 0.0.0.0, right? So for that, what you'll do is you'll just go to the directory of var/www/demo. So I'll just change it to demo, right? And then over here, you'll open the host file, right? So you'll just type in sudo vi/etc/host, right? So when you open this file, you can see that, you can mention the domain name and the IP address. So I'll just press on enter. So over here, I'll mention my domain name and the IP address. So let's say I consider the IP address to be 0.0.0.0. And then I mention the domain name to be sample.com, right? So once I'm done with that, I'll just save. So if I just open this file again, you can see that, we have mentioned our domain name and the IP address. So we'll just save this file and then we'll go back. Now what you have to do is you have to move your website static files to the server, right? So since you can't deliver your website if the server doesn't have your files, you just have to add your files to the server. So what you can simply do is you can just use the command scp-r star 0.0.0.0, and then you can just mention :var/www/demo, right? So what is basically happening is all the files are getting copied securely so that, your website static files are moved to the server, right? So I'll just press on enter. So I'll just continue with yes. So when I say yes, I just have to mention the password. All right. So you can see that, there's a permission denied. So that's basically because our files are not getting the permission. So what I'll first do is I'll just change the permission for the file. So for that, I'll type in the command sudo chmod -r 777, and let's say for all files, right? So I'll just mention start. And now I'll just run back the same command and let's mention the password. So when you mention the password, you can see that, these particular files have been moved to the server, right? So that's how you can just move the files. Now in this step, guys, let me just tell you one more thing over here. I'm doing it on localhost, so I've mentioned the IP to be 0.0.0.0. That's what I've mentioned in the file that I opened, right? The host file, right? But for example, if you're doing it for a remote server, what you can simply do is you just have to mention root @ and the IP address for that particular remote server, right? So I hope that's clear. So now what we'll do is we'll just configure our Nginx service to serve to our website, right? So basically, if you want to configure your Nginx service to serve to your website, let's just shift back to our Nginx folder first so that you can see the files available. And then I'll tell you how you can configure, right? So for that, what you can simply do is you can just type in cd/etc/nginx, right? So you'll just go back to the Nginx folder. So now in this Nginx folder, basically all the configuration files are located. So there are mainly two directories. So I'll just list and show you. So if you see, there are mainly two directories that you should be interested about. That is the sites available and the sites enabled. So basically in these two directories, what is happening is the sites available contains all the individual configuration files for all your possible static websites. And the sites enabled contains the links to the configuration files that the Nginx will actually read and run, right? So what's happening in sites available is it contains all the individual configuration files for all your possible static websites. And the sites enabled contains the links to the configuration files that Nginx will actually read and run, right? So what we're going to basically do is we're going to create a configuration file in the sites available, and then we're going to create a symbolic link to that file in the sites enabled to actually tell Nginx to run it, right? So I hope I'm clear with it. So what we're going to basically do is we're going to create a configuration file in the sites available and then create a link to the sites enabled file so that, we can actually tell Nginx to run that particular file, right? So for that, what you'll simply do is you'll just open the sites available directory. In that, you'll just open the demo folder and then you'll open a new file in which you're going to mention few parameters, right? So for that, you'll just type in sudo vi sites available/demo, right? So a new file has opened up. So over here, you can mention all the parameters. So I'll just mention server and then listen 80 default server. So that is basically a socket. Then I'll mention listen, colon, and then again we'll mention default server, right? Then I'll mention root, and then I'll mention the directory for the domain name, that is /var/www/demo. Then I'll mention in the index file. So index file in our application was index.html, right? So I'll just mention index.html, right? And then I'll mention server name to be demo. And then I'll mention location. And then I'll create a try catch block which says if the location doesn't match, then you can throw an error of 404, right? So I'll just mention that. So guys, that's all you have to mention. You just have to mention server, listen 80, default server, again, default server, and then you have to mention the root, and then you have to mention the domain names directory, then the index file, and then the try catch block, right? So this file basically tells Nginx several things. That is, it delivers files from the folder /var/www. Oh, my bad. I put an extra W over here, so I'll just change that. All right. So as I was saying, this file basically delivers files from the folder /var/www/demo. The main index page is called index.html. So the requests that are requesting for sample.com should be served by this particular server block. Now what you have to simply do is you just have to save this file, right? So I'll just go and save this file, and then your file is created, right? Now that your file is created, you just have to add this particular file to the site's enabled folder to tell Nginx to enable it, right? So for that, what you'll simply do is you'll type in the command sudo ln-s/etc/nginx/sites available/demo, and then copy to etc/nginx sites enabled, and then again copy it to demo, right? So basically all our files will be copied. So now moving forward, let me tell you that, our Nginx service was also running on our localhost 80, right? So since we've just configured our port number for our website also to be 80, both the Nginx server and your website are trying to access on the same port, right? So to just change that, what you can simply do is you can just change the default file in the enabled folder, and then you can remove that file and put it somewhere else, right? So what I'll simply do is I'll just move that file to somewhere else. So I'll just type in sudo move, that is mv, and then mention /etc/nginx/sites enabled/default. Let's say I'll mention it to be in the home folder. So I'll just type in home/edureka, and then I'll mention the file to be default, right? So I'll just move this to this particular directory. So the file has been moved. Now what you can simply do is you just have to restart your Nginx to enable this. So you just type in sudo systemctl restart Nginx, right? So you'll see that, your Nginx service has been restarted. So let's just open Firefox now, and then I'll mention 0.0.0.0. All right. So when I mentioned my IP address, that's what I mentioned over there. You'll see that, this is the particular application that we were trying to deploy, right? So it has features like toggle theme and toggle outline, but that's not an issue. Our main motive was to deploy an application using Nginx service, and we did that, right? So I hope that, you've understood how you can deploy a simple application using Nginx service. So guys, that was all for this particular session. I hope you found this session informative. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please.
All right, so that pretty much covers the lecture material for today. And what I want to briefly go over is I want to walk through today's lab. So let me publish the lab. You should have access to lab 7 now. And let me open the lab file. And I'll share my screen, of course. And so today, what we're going to do in just some real basic terms is, of course, connect everything. And then we're going to clone WinServer parent to WinServer web. and then start it up. Make sure it's on the VM network. So nothing should be on the internal. Now, by default, this server should be on the VM network, but just double check it. Then we're going to change the name of the server to server-web. And then I want you to write down or make note of the IP address. Then we're going to do the same thing with CentOS 8 parent to CentOS 8 web. And we're going to change the name to web server, which I tell you how to do that here. You just go become root and then hostname CTL set hostname web-server.cnet.lab. Now notice that the Windows is server-web and then CentOS is web-server. Okay. And that's on purpose so that they're different, but the same. Okay. And then you're going to make note of the web server's IP address. All right. Then we're going to go back over to the Windows server and we're going to install IIS. So go to Service Manager, add the web server role, and really just click next, next, next all the way through it. And then on CentOS, we're going to install Nginx with the commands here. So I have them typed out here. I don't have screenshots of them, but if you just type what is in between the parentheses here, you'll be good to go. Now, there is a video in here that gives you a very brief overview of using the Nano editor. The video where the lady was doing the Nginx, she was using the VI editor, which is standard on all Linux distributions. Nano is on CentOS and most Red Hat installs. And it's a little easier, in my opinion, to use Nano than it is VI. But there's a video here that you can watch. It's only a couple minutes long on getting started with Nano. Okay, and then you're going to go in, you're going to change line 41 of the Nginx conf file to the server underscore namespace web-server.cnet.lab, and then save the file. Then we're going to enable Nginx, start the service, punch a hole in the firewall for HTTP. We're not going to worry about HTTPS, not today. With that could be another video later on or another lecture later on. And then reload the firewall and away we go. And then the next thing we're going to do is on our Win10 client, again, make sure it's on the VM network and that your IP address is set to obtain automatically. That should be the case. That's where we left it last week. Okay, then we're going to go into Notepad, run as administrator, and this is on the Windows 10 client. And we're going to open the drivers, System32 drivers host file and modify it to look like this. So what we're going to do is this 10.29.72.58, that will be your IP address of your CentOS server. And then the www.virtual.host is the IP address of your CentOS web server. And then CNET.lab is www2. So anything with the www is CentOS. Anything with the www2 is Windows. Okay. And then put your Windows server IP address here. Okay. Don't put in my numbers because yours won't work. It won't work for you. So just put this at the end. And the first one is our default website. The second one will be our virtual website. All right. And then once you have that set up, just open a browser on Windows 10 and type in www.cnet.lab and then take a screenshot of the default CentOS website. So just paste that here. Then do the same thing with the www.cnet.lab and then paste a screenshot here. Okay, so that's the default websites. And then the next thing we're going to do is we're going to do some virtual domains. So within Server Manager, we're going to create a new website and we're going to call it new site, and we're going to give it the location of the new site, INET Pub new site, so that everything will be just like this on yours, and then hit OK. And then we're going to create an index.html file in the CINET Pub new site folder. So go into Notepad and make sure you save the file as, when it says save as file type text, change it to all files, and then save it as index.htm. And then just type this information in there. So from the start of the HTML tag until the end of the HTML tag, you'll just copy your this information in there. And then we'll do the same thing on the virtual host for CentOS. So here are the directions that you have to do here. And then we're going to restart, make the directory, restart Nginx, and then here are the commands. And the only thing is, don't use VI here where it says VI Etsy, change that to nano-c. We're going to use nano for that. And when you're done with all of this, type in the rest of the HTML code for your virtual site, and then you're going to test it by going to www.virtual.host, paste the screenshot of that website here, and then do the same thing for your Windows, www.2.virtualhost, and paste the website there, and then disconnect and submit. Okay, so pretty straightforward. There's not a lot of moving parts in today's lab, and the submit should say a file upload. Yeah, so you're good to go on that. All right, any questions on what we're doing in the lab? Now there is a video. I made a video of the lab where you can go in and watch me do the lab. So a lot of you have commented that you find the videos pretty helpful. So that's a great way for you to, if there's something in the write-up that you doesn't make sense, sometimes it's good to actually see how that's done. Now there is one spot in the lab video where I made a mistake. Instead of doing www.virtual.host, I put virtual.lab, and then I go back in the video and clean that up. So just follow along and you won't make that same mistake. The lecture or the instructions in the lab are correct. What I did on the video, I just did .lab. Should have been .lab.host.lab.host. So, but you'll see that when you watch the video. All right. And then of course, if you have any questions or comments, just ask them either out loud or in the discussion, the chat, and I'll be here to help you. All right. So the first thing you need to do is clone your WinServer-parent to WinServer-web, and then clone the CentOS 8-parent to CentOS 8-web. You should be very comfortable at this point of making clones. I did include I showed you how to do that in this week's video, but we've done that now for the last 3 weeks. And you're going to need to know how to do that for the lab midterm as well. So I'm going to stop recording this, and I'll be available for you until 2:40 if you need me. All right. Take your time. Try to understand what we're doing, and relate that back to the lecture material that we talked about today. And it should make sense on how to build a web server and then host a website on using both IIS and Nginx. All right.